Hello everyone, welcome to the Learnable channel. Today we'll be talking about planets of the solar system.
And this is in Unit 3, which is our solar system. Make sure to visit our website, which is probably going to be in the description of this video as well.
Yeah, it's also in our YouTube channel. This will be in our Astronomy 101 course. Please visit our website. It'll have quizzes, tests, and exams based on the content we're displaying right now. That'll give you a deeper understanding of what it is you're learning, and you'll have access to all our slides, as well as to learn about what our organization is and what our mission is. And yeah, so now let's talk about Mercury, which Bono will be talking about.
All right, so Mercury is the closest planet to the sun, being 29 to 43 million miles away from the sun because of its basically egg-like orbit. Its orbit is also only 88 Earth days long, being the closest planet, and it also has 0 moons. It rotates counterclockwise and finishes one rotation every 59 Earth days. And the temperatures can go from 800 at day to negative 290 at night degrees Fahrenheit. Mercury has a radius of 1,500 miles, about 2,400 kilometers, and around a third of the size of Earth. And it weighs that number, which is way too big to say for me. And its gravity is just about a third of what it is here on Earth, 3.7 meters per second squared. For example, a person weighing 100 pounds on Earth would weigh only just about 38 pounds on Mercury. Mercury also has a very, very thin atmosphere, making it impossible for us to breathe on it. It formed about 4.5 billion years ago, around the same as the other planets, and has 5 layers, which are a solid silicate crust and mantle, which is around 26 to 35 kilometers thick, and a solid iron sulfide outer core layer, a liquid core layer, and a solid inner core. And the radius of this is estimated to be just around 2,000 kilometers or 1,200 miles. And Mercury has a higher iron content than most planets. There are multiple theories for this, which we're going to talk about. The most widely accepted theory for this is the giant impact hypothesis, which originally had a metal-silicate ratio similar to common chondrite meteorites, which is typical of the solar system's rocky matter, and a mass approximately two and a half times its parent mass. Early in the solar system's history, Mercury may have been struck by a planetesimal approximately 1/6 Mercury's mass and may have been several thousand kilometers across. This impact would have stripped away much of the original crust and leaving the core behind as a relatively major component. Alternatively, Mercury may have formed from the solar nebula because before the sun's energy output stabilized. It would initially have twice the present mass, but as the protosyn contracted, temperatures could have raised super high, like 10,000 Kelvin. Much of the surface rock could have been vaporized at such temperatures, forming an atmosphere of rock vapor, which could have been carried away by the solar wind. A third hypothesis proposes that it could have been a solar nebula caused drag on the particles from which Mercury was accreting, which meant that lighter particles were locked in the accreting matter and not gathered by Mercury. The third hypothesis is the most likely one because the messenger craft in 2015 found higher than expected levels of potassium and sulfur, which would have been driven off by the vaporization of the crust or the giant impact. It is geologically inactive and has a bare appearance, lots of plains and basins, basically. And like the moon, with a heavy cratering because of the weak atmosphere. It's its magnetosphere is 1% as strong as Earth's and is not suitable for life whatsoever. And water has been discovered at the poles. And there have been 3 missions to Mercury so far: Mariner 10, Messenger, and Bepi-Colombo. Mariner 10 was the first to visit Mercury and made 3 flybys, revealing its surface and magnetic field. Messenger was the first to orbit Mercury and revealed its large core, offset magnetic field, and evidence the water ice on its poles. Bepi-Colombo is a joint mission between the ESA and JAXA, launched in 2018, and it captured its first user Mercury in 2021 and will begin its primary science mission in 2016. Now over to Monica to talk about Venus.
So Venus is Earth's sister planet. It is the second planet from the sun, 67 million miles away, or 108 million kilometers, with an orbit taking about 223 Earth days, with the day on Venus taking longer than a Venusian year, 245 Earth days, which is kind of weird. Venus has a thick atmosphere primarily composed of carbon dioxide with clouds of sulfuric acid, making it the hottest planet in our solar system. And the temperatures are around 900 degrees Fahrenheit. So the reason for that, like even though Mercury is much closer to the sun than Venus, and so logically Mercury should be hotter, the reason why Venus is hotter is because of all the sulfuric acid and carbon dioxide in the atmosphere. It makes a really strong greenhouse effect, which traps all the heat that came from the sun. And so that's why it's hotter than Mercury. Venus has a diameter of 7,520 miles or 12,100 kilometers. Venus weighs 1.073 times 10 to the 25 pounds. And the gravity there is 8.87 meters per second squared. So like compared to Earth's, Earth's is 9.2 meters per second squared. So they're pretty close. But there's this, so even though they're close, there's a slight difference. As on Earth, if you weigh 100 pounds, on Venus, you weigh around 91 pounds. So yeah, so now let's talk about the layers of Venus. So it has a metallic iron core that's roughly 2,400 miles wide. Venus, it has a mantle, and the mantle is a rocky mantle and is roughly 1,200 miles thick. And Venus's crust is mostly basalt and is estimated to be 6 to 12 miles thick on average. So yeah, Earth's crust is definitely way thicker, around 70 kilometers. So, and we'll talk about that later. So yeah, so now let's talk about Venus's atmosphere. So the atmosphere on Venus is filled with carbon dioxide and many other greenhouse gases which reflect heat and light back onto the planet, making it so that the surface heats up. The Venus's orbit is elliptical, so like an oval shape, but is the most circular out of all the planets in the solar system. Venus also spins clockwise, and Uranus are the only ones to have this type of spin. And there are theories as why did this happen, but the correct answer is not known. So it also means that it has a retrograde orbit. Possible hypothesis for this is mostly because like another planet could have like changed the way it rotates, but no one knows for sure. The surface of the planet has changed a lot. There was a planet resurfacing between 350 and 750 million years ago because of plate tectonics and other reasons. But today, Venus is a landscape of valleys, high mountains dotted with thousands of volcanoes. So the magnetic field is not created from the core of Venus, but is instead created from the sun's magnetic field. And Venus's outer atmosphere also has 0 moons. Venus formed around the same time as Mercury, 4.5 billion years ago, and has 3 layers. Venus is a land of extreme volcanism. It has a relatively young surface, one recently reshaped in geological terms, and chains of towering mountains. So now let's talk about Venus's atmospheric pressure. So the atmospheric pressure is very high, as it would press down on you as if you were a kilometer deep in the ocean. Venus could have had life in the past when the atmosphere wasn't as toxic and oceans were there, and there might be life in the atmosphere where extremophiles could live. So extremophiles are found in like near Earth's hydrothermal vents or geysers, like the one you see in the Yellowstone, because and they're called extremophiles because the place where they live is super like the temperature is very hot. Venus rotates clockwise because a planet size object hit Venus, which causes it to spin the other way around. Mariner 2 was the first successful flyby and revealed Venus as a runaway global hothouse. Venera 4 was the first successful atmospheric probe, and Venera 7 was the first successful landing. And Mariner 10 made a flyby of Venus. Sorry. Made a flyby of Venus en route to Mercury. Venera 9 and 10 were successful orbiters and landers. So now on to Banu to talk about Earth.
So Earth, our home planet, the third one to the sun, is 93 million miles away, with an orbit of 365.25 days to make one full orbit around the sun. And that 0.25, by the way, is what causes a leap year every 4 days, just so you know. And it completes one rotation in just about 23.9 hours. That number is super slowly increasing. It's increased by about just 1 millisecond per century since late 1600s. Earth also has one moon, which affects the tides and is the cause of its day slowing down. Its axis of rotation is tilted 23.4 degrees with respect to the plane of Earth's orbit around the sun, which is what causes the seasons. And the average temperature on Earth is 15 degrees Celsius or 59 degrees Fahrenheit, but has been getting hotter because of global warming. Earth also has a radius of just underneath 4,000 miles or 6,300 kilometers and weighs that number. It also has an atmosphere that consists of 78% nitrogen, 21% oxygen, and 1% other gases such as argon, carbon dioxide, and neon. With an elliptical orbit, Earth rotates counterclockwise like most other planets in the solar system. Gravity on Earth is 9.8 meters per second squared. And our planet's rapid rotation and molten nickel iron core give rise to the magnetic field, which is what causes compass needles to point to the North Pole, regardless of wherever you are and what you're facing. The magnetic polarity of Earth can change, flipping the direction of the magnetic field. And geologic records tell scientists that the magnetic reversal happens around every 400,000 years on average, but the timing is very irregular. Earth also has a diverse environment with an atmosphere that allows for the existence of liquid water, which is essential for life as we know it. It also has a pretty active geological presence with volcanoes and other things active all the time. And Earth formed around the same time as Mercury and other rocky planets in pretty much the same way.
Yeah. So now let's talk about the layers of Earth. So first let's talk about the innermost layer of Earth, which is the inner core. It is a solid ball of nickel and iron, roughly 70% the size of the moon. The temperature in the inner core is estimated to be between 4,000 to 5,000 degrees Celsius or 7,200 to 9,000 degrees Fahrenheit. The pressure at the center of the Earth is estimated to be around 360 gigapascals or 3.6 million atmospheres. So now, the outer core is the layer surrounding the inner core and is composed of liquid iron and nickel. The temperature in the outer core ranges from 4,000 to 5,000 degrees Celsius, and the pressure at the bottom of the outer core is estimated to be around 140 gigapascals. And or 1.4 million atmospheres. So that means it's 1.4 million times the pressure of Earth's atmosphere. So like the pressure you feel when you're outside, which basically feels like nothing. Then the lower mantle, which is the layer that lies between the upper mantle and the outer core. It is found between 672 and 2,890 kilometers below the surface and is made of solid rock. The rock is hot enough to melt, but it remains solid because of the pressure pushing down on it. The temperature in the lower mantle ranges from 1,900 to 2,600 Kelvin, and the pressure ranges from 24 to 127 gigapascals. Now for the upper mantle. The upper mantle is a very thick layer of rock just inside Earth that begins just beneath the crust. at about 10 kilometers under the oceans and about 35 kilometers under the continents, and ends and at the top of the lower mantle at 670 kilometers. The temperature in the upper mantle ranges from approximately 500 Kelvin, 227 degrees Celsius or 440 degrees Fahrenheit at the upper boundary, with the crust to approximately 1,200 Kelvin at the boundary with the lower mantle. Now let's talk about the asthenosphere. The asthenosphere is the mechanically weak and ductile region of the upper mantle that lies below the lithosphere. It is located at a depth between 80 to 200 kilometers below the surface and extends as deep as 700 kilometers. It is on these layers that the tectonic plates move. Then the lithosphere. The lithosphere is the outermost layer of Earth and includes the crust and the uppermost part of the mantle. It is a rigid layer that is broken into tectonic plates, and the thickness of the lithosphere varies depending on location, but it is generally on 5 to 200 kilometers thick. The continental crust is the layer of granitic, sedimentary, and metamorphic rocks that forms the continents and the areas of shallow seabed close to their shores. It is generally thicker and less dense than the oceanic crust. The thickness of the continental crust varies, but it averages around 35 to 40 kilometers. The oceanic crust is a layer of basaltic and igneous rock that forms the ocean floor. It is thinner and denser than the continental crust, and the thickness of the oceanic crust varies, but it is around 7 to 10 kilometers. Now let's talk about the troposphere. The troposphere is the lowest layer of Earth's atmosphere and extends from the Earth's surface to an altitude of about 8 to 14.5 kilometers, or 5 to 9 miles. This part of the atmosphere is the most dense and is almost where all the weather occurs in this region. The stratosphere is a layer above the troposphere and extends to an altitude about 50 kilometers or 31 miles. The ozone layer, which absorbs and scatters solar ultraviolet radiation, is located in this layer. Now to the ozone layer. The ozone layer is the region of Earth's stratosphere that contains a high concentration of ozone or O3 molecules. It absorbs most of the sun's ultraviolet radiation, which is harmful to life on Earth. The ozone layer is located at an altitude of about 10 to 50 kilometers or 6 to 31 miles above the Earth's surface. Now the mesosphere. The mesosphere is the layer above the stratosphere and extends to an altitude of about 85 kilometers or 53 miles. Meteors burn up in this layer. Now the thermosphere. The thermosphere is a layer above the mesosphere and extends to an altitude about 600 kilometers. Auroras and satellites occur in this region. Auroras are natural light displays that occur in the polar regions. They are caused by the interaction of energetic particles, electrons, and protons from the solar wind with atoms in Earth's upper atmosphere. The particles are guided by Earth's magnetic fields into the polar regions, where they collide with atoms and molecules in the atmosphere, causing them to emit light. Now on to the ionosphere. The ionosphere is the layer of Earth's atmosphere that contains a high concentration of ions and free electrons and is able to reflect radio waves. It lies above the mesosphere and extends from about 50 to 600 kilometers above the Earth's surface. Now to the exosphere. The exosphere is the outermost layer of Earth's atmosphere and extends from the top of the thermosphere up to about 10,000 kilometers away from the Earth's surface. Now the magnetosphere. The magnetosphere is the region of space surrounding Earth where the planet's magnetic field dominates. It is shaped between the interaction of solar wind and Earth's magnetic field. The magnetosphere protects Earth from harmful solar and cosmic radiation by deflecting charged particles away from the planet. Now on to Banu about the seasons of Earth.
So, like I said earlier, the seasons on Earth are created due to the tilt of the Earth's axis, which is tilted at just around 23.4 degrees. which means this tilt means that different parts of the Earth receive more solar energy than others. It also causes Earth to orbit the sun at a slant, which means that different areas of the Earth point towards or away from the sun at different times of the year. During the June solstice, the North Pole is tilted towards the sun, and the northern hemisphere receives more of the sun's direct rays. This is why June, July, and August are some months in the northern hemisphere. At the same time, the southern hemisphere points away from the sun, creating winter during these months. And the opposite is in the summer solstice, which is where it is summer in the southern hemisphere and winter in the northern hemisphere. And on the tides. Tides are Earth caused by the gravitational pull of the moon, which generates something called the tidal force. This force causes Earth and its water to bulge out on the side closest to the moon, and the side furthest from the moon. The side closest and the furthest from the moon. These bulges of water are called high tides. As the Earth rotates, your region of Earth passes through both of these bulges every day. And when you're in one of these bulges, you experience a high tide. When you're not, you experience a low tide. And this cycle occurs most days on most of the coastlines on the world. And on to monitor for Mars.
So Mars is the fourth planet from the sun and is around 142 million miles away from the sun. It is often referred to as a red planet due to the reddish appearance. Mars also has two moons, which may be rogue asteroids caught by Mars's gravity, and one of Mars's moons, called Phobos, will collide with Mars in about 50 million years. One rotation for Mars is around 24.6 hours, so similar to Earth, and its orbit is 687 Earth days, or 669.6 sols, which are Martian days. And they are also short for solar days. Mars's axis of rotation is tilted 25 degrees with respect to the plane of its orbit around the sun. And similar to Earth with its tilt of its axis of 23.4 degrees. This means that Mars has similar seasons to Earth, while here on Earth the seasons are evenly spread out over the year. On Mars, the seasons vary in length because of Mars' elliptical egg-shaped orbit around the sun. Spring in the northern hemisphere, autumn in the southern, is the longest season at 194 sols. Autumn is in the northern hemisphere. Spring is in the southern. Is the shortest at 142 days. Northern in the winter winter season in the northern hemisphere, or summer season in the southern hemisphere, is 154 sols, and the northern summer/southern winter is 178 sols. Mars has a radius of 2,106 miles, and it weighs that number. Its gravity is 3.71 meters per second square, so it's around a third of Earth's gravity, meaning a 100-pound person would weigh about 38 pounds. Mars has many colors on its surface, and its volcanoes, impact craters, tectonic plate movement, and atmospheric conditions, such as dust storms, have altered the landscape of Mars over many years, creating some of the solar system's most interesting topographical features. This makes Mars very geologically active. Mars has no global magnetic field today, but areas of the Martian crust in the southern hemisphere are highly magnetized, indicating traces of a magnetic field from about 4 billion years ago. Mars also has clockwise rotation, and same as Earth's. Yeah. Okay. So Mars has a thin atmosphere and polar ice caps, and it's been a focus of scientific interest due to its potential to have supported life in the past and its potential for human exploration. Mars formed around the same time as Mercury and other rocky planets in pretty much the same way, and most features of the rocky inner planets are the same. Mars has a thin atmosphere made up of mostly carbon dioxide, nitrogen, and argon gases. Mars' sparse atmosphere doesn't offer much protection from impacts by such objects as meteorites, asteroids, and comets. It also has 3 layers. Mars may have had life before the oceans have frozen up because it is not in the Goldilocks zone. There have been many missions to Mars, both past and present, with more planned for the future. Some of the past missions include the Mariner 4 spacecraft, which swung close by Mars in 1965 and captured the first close-up images of the planet. In 1971, the Soviet space probe sent the first spacecraft into Martian orbit. The currently operational on Mars are one lander InSight and three rovers, NASA's Curiosity and Perseverance, and China's Zhurong rover, with another rover, ExoMars, planned for launch next year. Orbiting Mars are 8 satellites, providing massive amounts of data on our dusty neighbor. More missions are planned for the 2022 and 2024 launch windows, and there are many proposals to put humans on Mars by 2030s. And as you know, SpaceX is contributing a lot to bringing humans on Mars. So now let's talk about the layers of Mars. So the Martian crust is thinner than expected and may have 2 or even 3 sublayers. It goes as deep as 12 miles, 20 kilometers, if there's 2 sublayers, or 23 miles if there are 3. Such a thin crust may contain a relatively high proportion of radioactive elements. The mantle extends 969 miles below the surface. The lithosphere of more solid rock reaches 400 to 600 kilometers down, twice as deep as on Earth. This could be because there's only one continental plate on Mars, in contrast to Earth's with its 7 large mobile plates. The Martian mantle is mineral geologically similar to Earth's upper mantle, but contains more iron than Earth's. The core of Mars has a radius of about 1,840 kilometers or 1,140 miles, making it a good 200 kilometers larger than had been assumed 15 years ago. Like Earth, Mars appears to have a molten iron core, or at least a molten outer core. And by the way, the reason behind Mars being so red is because the soil of Mars is like rusty, kind of like when iron gets rusted. So yeah. So on to Bonnet to talk about Jupiter.
All right, so Jupiter, the fifth planet from the Sun, is around 484 million miles away, or 778 million kilometers away. It is also the biggest planet by far in the solar system, more than twice as massive as all the other planets combined. And it has a diameter of around 88,000 miles, or 143,000 kilometers. Jupiter has an orbit of just around 11.5 Earth years, and a day on Jupiter is only just underneath 10 Earth hours, which is very short. Jupiter also has 80 to 95 moons, which makes it the planet to have the most Saturn. These contain confirmants and some proposed, which have not been officially observed yet. The surface temperature is around a negative 160 degrees Fahrenheit, or negative 110 degrees Celsius. It also weighs that big number. And with its orbit being elliptical and counterclockwise, it has a typical orbit. Jupiter also has some massive gravity, 24.79 meters per second squared, because of its immense size. And it also is thought that there might be no surface on Jupiter, as it might be a failed star that wasn't able to start nuclear fusion. And the layers for this planet, there's likely 3. The top cloud is probably made of ammonia ice, with the middle layer being made of ammonium hydrosulfide crystals, and the innermost layer maybe being made of water ice and vapor. Scientists propose one of 2 scenarios for the formation of Jupiter. If the planet created first as a solid body, it would consist of a dense core, with a layer of liquid metallic hydrogen surrounding it, and which would be covering around 80% of the planet. It would also have an outer atmosphere made of molecular hydrogen. Alternatively, if the planet collapsed directly from the protoplanetary disk, it was made of, it's thought to lack a core, consisting instead of molecular and metallic hydrogen all the way to the center. The magnetic field of Jupiter is also very big, 600,000 to 2 million miles, which is 1 to 3 million kilometers. And it extends from 7 to 21 pounds in diameter of Jupiter itself. The atmosphere is pretty much makes up the planet and pathways, which we talked about. And the structure and the layers also kind of resemble the sun. Jupiter's red spot is caused by a huge hurricane, which is the size of Earth, but it'll die down in the next 100 years. So we're not going to see it for very long. And for the missions, there have been quite a few missions, including Pioneer 10 and 11, which were the first spacecraft to cross the asteroid belt and observe Jupiter's rings and moons. Voyager 1 and 2, which discovered volcanic activity on Io, new moons, and more details of the rings. Galileo, which made discoveries, geological discoveries on all 4 of Jupiter's large moons, and dropped a probe into Jupiter's atmosphere. Ulysses, which used Jupiter's gravity to explore the sun's polar region. Cassini-Huygens, which took high-resolution images of the planet and its storms. And Juno, which has provided and is still providing new insights into Jupiter's composition, structure, and space environment. And on to talk about Saturn.
So now let's talk about Saturn. Saturn, the 6th planet from the sun, around 886 million miles away. It has an orbit length of 29 Earth years and a rotation length of 10.7 hours. Saturn's year and day are similar to Jupiter. Its axis is tilted by 26.73 degrees with respect to its orbit around the sun, which is similar to Earth's 23.4 degree tilt. This means, like Earth, Saturn experiences seasons. The average surface temperature of Saturn is negative 220 degrees Fahrenheit. Saturn has a radius of 36,183.7 miles and weighs that number. Saturn has an elliptical counterclockwise orbit like most other planets. Saturn's gravity is 10.44 meters per second squared. It is thought there might be no surface on Saturn as it is made up of a lot of dust similar to Jupiter. The magnetic field of Saturn is smaller than Jupiter's, but still 578 times as powerful as Earth's. Aurorae still occur when charged particles spiral into a planet's atmosphere along the magnetic lines. On Earth, these charged particles come from the solar wind. Cassini showed that at least some of the Saturn aurorae, like Jupiter's, are largely unaffected by solar wind. Instead, these aurorae are caused by a combination of particles ejected from Saturn's moons and Saturn's magnetic field's rapid rotation rate. But these non-solar originating auroras are not completely understood yet. The atmosphere of Saturn is pretty much makes up the planet and has layers and acts as the planet's surface. Now let's talk about the missions to Saturn. So there have been a number of missions, 3 missions to Saturn so far. So Pioneer 11 in 1979 was the first spacecraft to reach Saturn and discovered Saturn's F ring and a new moon. Voyager 1 in 1980 sent back high-resolution images of the planet, rings, and satellites and discovered several new moons of the volcanic activity on Io surface. Voyager 2 in 1981 provided more detailed images and documented the thinness of some of the rings. The Cassini spacecraft from 2004 to 2017 discovered on Pleiades' south polar geysers, the source of Saturn's east ring, Titan's methane cycle, including rain that causes hydrocarbon lakes, dynamic rings to containing ice, silicates, and organics. Saturn's differential rotation propeller-like formations in Saturn's dynamic ring system, the possible birth of a new moon, and one of the most active chaotic rings in our solar system, Saturn's F rings. Now, the rings of Saturn will disappear, but it'll take a very long time. So yeah. So now let's talk about the layers of Saturn. At Saturn's center is a dense core of metal like iron and nickel surrounded by rocky material and other compounds solidified by intense pressure and heat. This causes the magnetic field we see from Saturn. The central core is surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen, and liquid helium, and finally a gaseous outer layer. Saturn has a pale yellow hue due to the ammonia crystals in its upper atmosphere. Saturn's rings are divided into several major divisions. Listed here are from the innermost to the outermost. So let's start off with the D ring. The D ring is the innermost ring and is very faint. The C ring is the next ring out from the D ring and is also relatively faint. The B ring is the next ring out from the C ring and is the brightest and most massive of all rings. The Cassini division is a gap between the B and A rings that is about 980 miles or 4,800 kilometers wide. Then comes the A ring and is also relatively bright. Then is the Roche division, which is a gap between A and F ring that is about 2,600 kilometers wide. Then is the F ring and which is a narrow ring just outside of the A ring. Then is the Janus Ephemeris ring, which is a faint ring located just beyond the F ring. Then comes the G ring and is a faint ring just located beyond the Janus Ephemeris ring. Then comes the metone and onto-ring arcs. The metone and onto-ring arcs are faint arcs located just beyond the G ring. The E ring is the outermost ring and is the largest and there's the largest ring, spanning 621,370 miles, about 1 million kilometers, and it consists of many tiny micron, submicron particles of water ice with silicates, carbon dioxide, and ammonia. The E ring is distributed between the orbits of Mimas and Titan. The particles in Saturn's rings are composed primarily of water ice and range in size from microns to tens of meters. Galileo discovered Saturn's rings in 1610. The origin of the rings of Saturn, Uranus, Neptune, and Jupiter is uncertain, and there are several theories. One theory suggests that the rings formed from the debris of the moon that broke up in orbit around the planets due to their strong gravity. Another theory suggests that the rings are leftover material from the planet's formation. For example, some scientists propose that the Saturn's rings formed when a moon was destroyed 100 to 200 million years ago, which also caused Saturn's rotation axis to tilt. And one more quick thing, the pale blue dot you see right next to Saturn is Earth. So you can see how small Earth is compared to all our other planets in our solar system and how far away it is from Saturn. So now on to Banu to talk about Uranus.
So, Uranus is the seventh planet from the Sun, 1.8 billion miles away, and has 27 million years. Its orbit is around 84 Earth years and rotates once every 17 hours. This means each season is 21 years long, and one pole gets complete sunlight for 21 years, while the other pole is in complete darkness for those same 21 years. That's crazy. The average surface temperature is negative 320 degrees Fahrenheit, negative 195 degrees Celsius. Uranus also has a radius of just underneath 16,000 miles, or 25.3 kilometers, 25,000 kilometers, and weighs that big number. The atmosphere is mostly hydrogen and helium with some ammonia, water, and methane mixed in. This methane is what causes the blue color that you see. Uranus's orbit is nearly circular and clockwise, but those aren't the only differences from the planets either. It also rotates. Actually, well, I'll talk about it later. For now, let's just talk about the layers. Uranus has 3 layers: a rocky silicate iron nickel core in the center, an icy mantle in the middle, and an outer gaseous hydrogen and helium envelope. The core's mass is estimated to be about half of Earth's mass with a radius less than 20% of Uranus. The Uranian atmosphere can be divided into 5 main layers: the troposphere, the stratosphere, the thermosphere. Sorry, 3 different layers. And between altitudes of negative 350 kilometers for the troposphere and pressures from 100 to 0.1 bar. The stratosphere has an altitude of 50 to 4,000 kilometers and pressures of between 0.1 and 10 bar. And the hot thermosphere and exosphere extend from an altitude of 4,000 kilometers to several Uranian radii from the normal surface at 1 bar pressure. Unlike Earth's, Uranus's atmosphere has no mesosphere. The troposphere also hosts 4 cloud layers: methane clouds at about 1.2 bar, hydrogen sulfide and ammonia clouds at 3 to 10 bar, and ammonium hydrosulfide clouds at 20 to 40 bars. And finally, water clouds below 50 bar. Above the clouds lie several tenuous layers of photochemical haze. So that very different part that I was talking about earlier, it has a tilt of over 90 degrees. Yeah. This is possibly the result of a collision with an Earth-sized object long ago. The gravity on Uranus is around 8.87 meters per second squared, around 89% of Earth's gravity. There's also no real on the diagram, but I kind of talked about that earlier. And Uranus also has an unusual, irregularly shaped magnetic field, as it is also tipped over, around 60 degrees from the planet's axis of rotation, and is also offset from the center of the planet by 1/3 of the planet's radius. The auroras on Uranus are not in line with the poles due to the lopsided magnetic field, and William Herschel also discovered Uranus, and Uranus was the first planet to be discovered using a telescope, which is pretty cool. Let's talk about the rings. The ring system of Uranus consists of 13 different distinct rings. In order of increasing distance from the planet, they are that first one, which I don't even know how to start saying. And the next ring is the 6, 5, 4, A, B, N, Y, O. I don't know the names of the other 4, but they're on the screen. And they can be divided into 3 groups: 9 narrow main rings, which are the 6, 5, 4, A, B, N, Y, O, and the 3 looking one, and 2 dusty rings, which is the big one I didn't talk about, and one of the symbols, the A kinda, and the 2 outer rings, which is the V and the U with the line. The rings were discovered on March 10th of 1977 by James L. Elliott, Edward W. Dunham, and Jessica May. The rings of Uranus are probably composed of water ice with the addition of some dark radiation process organics. The proportion of dust in the rings is high, while their optical depth is low to moderate. I also want to talk about Neptune.
Yeah, so before we talk about that, let's talk about the missions to Uranus.
Oh yeah, sorry. Yeah, it was just Voyager 2. So yeah.
Yeah, so Voyager 2 visited Uranus and discovered 10 new moons, 2 new ring systems, and a magnetic field that was off-center. That the planet's rotation was tilted more than any other planet in the solar system. And one more thing, so on like Saturn, so Saturn is like so less dense compared to Earth that like if there was a large enough body of water, it could float on it, which is pretty crazy and cool. So now let's talk about Neptune. So Neptune is the last planet from the sun and is around 2.8 billion miles away, having 14 known moons. Neptune orbits around the sun once every 165 Earth years, so it's a very, very long orbit. And the day on Neptune takes about 16 hours. Neptune's average surface temperature is negative 200 degrees Celsius or negative 392 degrees Fahrenheit. Neptune has a radius of 15,299.4 miles and weighs approximately that number. Neptune's atmosphere is made up of mostly hydrogen, helium with just a little bit of methane, but Neptune's atmosphere is more vivid blue compared to Uranus's atmosphere. Uranus' atmosphere is like greenish tealish color. This is because an unknown element in the atmosphere. So that's why it's blue. We don't know what that element is yet. Neptune's orbit is elliptical and rotates counterclockwise. Neptune's gravity is 11.15 meters per second squared, which is about 1.14 times as much as Earth's. Neptune has two layers. Neptune has no real surface like the terrestrial planets or / inner planets. Urban Le Verrier, John Gorford Galley, and John Couch Adams discovered Neptune in 1846. Neptune has a great dark spot, which is a hurricane the size of Earth. The new observations indicate that the dark spots are likely the result of air particles darkening in a layer below the main visible haze layer, as ices and hazes mix in the Neptune's atmosphere. So now let's talk about the layers of Neptune. So Neptune is a gas giant which has no definite surface layer. Instead, the gas gradually transitions into a slushy ice and water layer. And the interior of Neptune is made up of two layers, a core and a mantle. The core is composed of rock and metals, and the mantle is a mixture of water and water, ammonia, and methane ices. Neptune's atmosphere is divided into two main layers, the troposphere, where temperature decreases with altitude, and the stratosphere, where the temperature increases with altitude. The boundary between the lower troposphere and the stratosphere is called a tropopause. Neptune's atmosphere is primarily made up of hydrogen and helium with some methane. The methane is part of what gives Neptune its brilliant blue tint, as it absorbs the red light and reflects bluer colors. So now let's talk about Neptune's magnetic field. So its magnetic field is tipped over by about 47 degrees compared with the planet's rotation axis, like Uranus, with its 60-degree tilted magnetic variations during each rotation because of its misalignment. The magnetic field of Neptune is 27 times more powerful than that of Earth's. So now let's talk about the missions to Neptune. So only one spacecraft has visited Neptune so far, which is Voyager 2. It discovered the Great Dark Spot, 6 new moons, 4 rings, and evidence of geyser-like eruptions on Triton, a moon of Neptune. So now let's talk about the rings of Neptune. Neptune has 5 principal rings named after the astronomers who made important discoveries about the planet. Increasing distance from the planet, they are Galley, Le Verrier, Lasswell, Argo, and Adams. The rings are composed of at least 20% of dust, with some rings containing as much as 70% dust. The rest of the material comprising the rock ring is small rocks. They were first discovered by simultaneous observations of stellar occultation on the 22nd of July in 1984 by Andre Barrix and William B. Hubbard's teams at the La Silla Observatory and the Cerro Tolo Inter-American Observatory in Chile. So now let's talk about dwarf planets. So there are 5 officially recognized dwarf planets in our solar system, and they are Ceres, which is located in the asteroid belt between Mars and Jupiter, and it was discovered by Giusio Piazzi in 1801. Then Pluto, located in the Kuiper Belt, a region of icy objects beyond the orbit of Neptune, and was discovered in 2005 by the same people who discovered Eris. And then Hanume, also located in the Kuiper Belt and discovered in 2005 by the same people who discovered Eris. And then Makemake, also located in the Kuiper Belt and discovered by the same people who discovered Eris. Then Eris, which is located in the scatter disk, a distant region of the solar system beyond the Kuiper Belt. It is 97.5 AU from the sun at the aphelion, the furthest distance from the sun. It is the biggest dwarf planets, and Michael E. Brown, Chad Trulio, and David L. Rabinowitz discovered in 2005, and Pluto, located in the Kuiper Belt, discovered by Edwin Hubble. So the requirements to be a planet, according to the International Astronomical Union, it has to meet three criteria. So it has to orbit a star. It has to be big enough to have gravity to force in a spherical shape, and it must be big enough that its gravity cleared away any objects of a similar size near its orbit. Dwarf planets are different from planets because they have not cleared their orbital paths. So yes, they might orbit a star, they might be in a spherical shape, but they have not cleared their orbital paths. So that's why they're called dwarf planet. Planets, so this means that the dwarf planets this means that planets have orbital dominance, meaning they have cleared their orbit from every object, either by capturing it as the moon, colliding with it, pushing it away due to gravitational disturbance. So the IAO just first designated Pluto, Eris, and Ceres as the first dwarf planets. So now on to Banu to talk about rogue planets.
So, what are rogue planets? They're also termed as free-floating planet, interstellar, nomad, orphan, starless, unbound, or wandering planet. A rogue planet is an interstellar object of planetary mass, which is not gravitationally bound to any star or ground source. Rogue planets originate from planetary systems, in which they're formed, but later ejected for some unknown reason. They can also form on their own outside of planetary system, but they're also difficult to detect because they don't orbit the stars, so they don't reflect any light. However, some rogue planets have been discovered through their gravitational effects on other objects or by observing their super faint heat signatures. For example, in 2021, astronomers discovered a group of over 70 rogue planets located within the Scorpius and whatever that is, constellations, basically between two constellations. And in 2020, an Earth mass rogue planet named OGLE-2016-BLG-1928 was discovered. Now on to Pluto.
Which Banu will be.
Yeah. Located in the Kuiper Belt, Pluto's highly eccentric oval-shaped orbit brings it inside Neptune's orbit for a 20-year period every 248 Earth days. It is the largest known trans-Neptunian object by volume, by a small margin, because it's slightly less massive than Eris. Pluto also has 5 known moons. Charon, the largest with a diameter just over half of Pluto, Styx, Nix, Kerberos, and Hydra 2. Pluto and Charon are sometimes considered a binary system because the very center of their orbits does not lie within either body. Pluto's atmosphere is composed mostly of nitrogen, methane, and carbon monoxide. The surface area of Pluto is 1.795 times 10 to the 7th square kilometers, about 0.03% of the surface area of Earth. When Pluto is the furthest away from the sun, gases like nitrogen, carbon monoxide, and methane partially freeze onto its surface. Pluto's rotation is retrograde, basically, which means it rotates backwards from east to west. Uranus and Venus also have the same retrograde rotation, so which one I talked about earlier. And for comparison, our moon is 20 times further away from Earth. Pluto and Charon are also referred to as a double planet. Charon's orbit around Pluto takes 153 hours, the same time it takes Pluto to complete one rotation. Pluto has a moderately eccentric and inclined orbit ranging from 30 to 49 astronomical units, 4.5 to 7.3 billion kilometers, or 2.8 to 4.6 billion miles from the sun. Light from the sun takes 5.5 hours to reach Pluto at its orbital distance of 39.5 AU. Astronomical units, which is just underneath 6 billion kilometers and 3.6 billion miles. It is not known whether or not Pluto has a magnetosphere, and scientists were very surprised to find that Jupiter's icy moon, Ganymede, had a magnetosphere because it's very hard to explain how an icy body can go out there. Anyway, Pluto may well have a magnetic field as a result of its true orbit with the moon, with its moon turn. Pluto's surface is icy and dark with a molasses-colored mottled appearance. The surface undergoes seasonal changes in color and brightness, and Pluto has varied landscapes which include created uplands, parallel ridges of the washboard terrain, chaotic and angular mountain ranges, cellular plains, coarsely pitted areas of sublimating nitrogen ice, zones of thin nitrogen ice break over the topography below, and dark mountainous highlands scattered by deep pits. Pluto's radius is 738 miles, while Earth's radius is just underneath 4,000 miles, and the moon's radius is 1,000 kilometers. So Pluto is smaller than both the moon and Earth. On the dwarf planet on Pluto, the reddish color is likely caused by hydrocarbon molecules that are formed when cosmic rays and solar ultraviolet light interact with methane in Pluto's atmosphere and on its surface. Also has a water ice crust, subsurface ocean, and a solar-kit rock. Life could exist in the subsurface ocean, and Pluto was discovered by Clyde Tombaugh in 1930. For its layers, Pluto is believed to have a rocky core surrounded by a layer of water ice with methane on top. The frozen nitrogen, carbon monoxide, and methane observed on its surface are in the form of a relatively thin layer, similar to the layer of water on Earth's surface. About 75% of Pluto is rock, about 20% is water ice, and about 5% is methane ice. And there's only been one mission to Pluto so far, which is New Horizons in 2015. It was the first spacecraft to visit Pluto, discovered its vast nitrogen glaciers, towering ice mountains, and a massive subsurface ocean.
Yeah, so that's it for today, guys. In our next video, we'll be talking about the history of mankind in our solar system and space exploration. So please watch that. And we worked really hard on this video, so like if you could please like, subscribe, and share this video and this YouTube channel perhaps, that would help us a lot. And you'll help us reach a wider audience and help this organization reach more people and educate more people. And so thanks for watching again. Bye.
Bye.